Yeah, that's a really good point. I want to ask you more about that, but I think we're kind of naturally segueing into a different form of the argument. So I made notes to remind myself. I do want to ask you about this again. Um, so the argument from design has a couple of different flavors to it. One of the probably the most popular is the argument from biological design. So we've already talked about Bailey. Bailey was the first to really put this forward in a concrete way. Paley, not Bailey. Paley. Sorry, Paley. Um, Paley said that the watchmaker analogy is analogy. So even if you don't, maybe it's a bad analogy, false analogy. But Paley said if you look at nature, this is what I think gives the argument a lot of appeal because it can be very like concrete as opposed to other arguments for the existence of God, which are based on the logical structure. Like the ontological argument is just words, right? There's no like concrete thing to point to. But Paley says no. Look at the eyeball, right? The eyeball is so complex that no naturalistic biological explanation you can give can explain how it was formed. Now, of course, Darwin explained it, but it didn't defeat the argument because it kind of came back with a vengeance in the latter part of the 20th century, made famous by Michael Behe. Behe or Behe? I never get his name right.
It is Behe.
Behe. Okay. I'm sorry, Michael. Come on the channel. I'll be more than happy to get your name correct. Behe wrote a book early 90s. I can't remember when it was. It was in the 90s called Darwin's Black Box. And Behe introduced this idea of irreducible complexity. That there are certain things in nature that, now, of course, 20th century, we got the acceptance of Darwinian evolution, the neo-Darwinian synthesis. Darwinian evolution is now an established scientific theory, right? It's no other competing explanation even comes close. But
Right.
Behe said, even if we grant Darwinian evolution, there are still some things we can observe. I think the examples he gives are usually from microbiology, the structure of the cell, the flagellum. There are still some things that we can observe and point to that can't be explained via natural selection. Therefore, the best explanation we have of these concrete biological entities is that they must have been designed. So let's start there. How would you respond to this, the biological version of this argument?
Well, so for specifically irreducible complexity, I know you mentioned the flagellum, and that's obviously false. I feel like this is somebody that hasn't actually done the research on like current, at least current academic or scientific endeavors into learning about like bacterial flagellum and just flagellum in general, because Behe and other intelligent design people say that, well, the flagellum, if you remove just one protein or remove just one part of the flagellum, it breaks apart and it doesn't work. But the problem is that that's not true. We have scientific experiments where people have modified the genetic code of the bacteria to remove certain proteins from the flagellum, and the only effect that it has is that it reduces the mobility of it. And so as you go backwards in what seems to be the evolution of the bacterial flagellum, as you remove these proteins and these working parts from the flagellum, you find that the flagellum is worse at doing its job. It never goes away. It never doesn't form or whatever. It just reduces its mobility. So it kind of seems like as single-celled organisms developed, this motor flagellum structure, right? It seems to just evolve to do its job better and better, almost as if as these bacteria were evolving and changing and everything like that, the bacteria whose flagellum could move them faster and better were able to survive and propagate, while those that had the worst versions of the flagellum seemed to die off. And so as these bacteria progressed, forward in their evolutionary line, they just kept getting better and better flagellum to the point where it does its job as good as the environment will allow it to. And see, that's the thing that a lot of people don't really understand about what we perceive as complexity or specific design in nature. Because what we're looking at is the end, or well, not the end product, because everything's always evolving. It's a continuous process. But we're looking at the current organism as it exists now. The thing is, though, is that that's not how that group of organisms, or how organisms similar to that organism has always existed. And just because we're seeing how the organism works or how it exists in its own environment now, doesn't mean that it's always been that way. For instance, there's Neil deGrasse Tyson in the Cosmos series made the I guess not hypothesis, but he gave an example of like a brown bear. And it's like, well, how would a brown bear turn white, into a polar bear? Well, let's say that the brown bears, living in North America and everything like that, the brown coat gives it camouflage in the woods. Well, let's say that they keep moving north. And as they keep moving north, there's more snow, there's lighter terrain. And so the bears that retain, as the group of organisms, they progress generation by generation. As they retain their brown coats, they're easily picked off by predators or whatever. They're easily killed. Whereas the bears with lighter coats are able to survive and propagate. And so after generations and generations of this, you end up with polar bears, or white bears. And so they're able to blend in with the environment. They're able to survive better. And of course, it's not that these traits develop in a vacuum. The organisms respond to the environment that they're in. So if an organism moves from one environment to another, they're obviously going to be shaped by that environment. And that's just due to what traits does the organism have, or what traits does the organism develop that allows it to survive in that environment. And so a lot of people like to use the I don't know why I'm blanking on his name, but he wrote the Douglas Adams. Adams. Everybody loves to use Douglas Adams' puddle analogy. And if you don't know what that is, Douglas Adams gave an example of an anthropomorphized puddle of water. And basically the puddle of water is like, oh, this hole, it seems to fit me so perfectly well. It must have been made for me specifically. But in reality, the water is actually just taking on the shape of the puddle. It's taking on the shape of the environment that it's in. And so I feel like that's what a lot of people are doing with this particular argument. They're saying, oh, look, this animal is, perfectly suited for the environment that they're in. It must have been made to live in this environment. But they fail to understand that the environment that they're in kind of, it shapes quite literally what the organism looks like, what its traits are, and how it survives. And so given that the face of our planet has changed so much over the millions and billions of years that life has been here, it only makes sense that organisms, move to different environments. and then they would subsequently change in order to survive better in that environment. And um, I think that people oftentimes forget that like a brown bear is not going to be very suited to live in the Arctic, right? But that's because they don't have the millions of years of genetic changes that polar bears do, you know? And so people just, they don't realize that the environment plays a pretty big factor into what we perceive as design.
Yeah, in explaining that, it brought a smile to my face because you also explained natural selection so well.
did I? I hope I did. Normally, whenever I start talking about science, I get people in the comments angrily typing like, "Oh, you messed this up. It's not this. It's really that."
Yeah, there's always going to be those people. I usually get them in the classroom. Um, I I like it because there was a phrase. I don't want to. This will be something somebody else could complain about. I don't want to misattribute it to Darwin. I think it was either Darwin or Huxley talked about natural selection as. I think they said it was. It appeared designed without the designer. So, like, if you look at Darwin was really big into studying barnacles and orchids, right? Super exciting hobby is to sit there and stare at barnacles for years on end. But he writes in I think it's in his it might be I can't remember where it was. I'm confusing myself. But he writes he has this letter that he writes and he says like if you were going to design the perfect creature suitable for this habitat, you design a barnacle. Like it fits so well. And so, based off what you're saying, it seems like the mistake in reasoning would be just to take the current snapshot of the barnacle and say, "Aha!" Right there we have it. Like this creature is so well suited that it's like finding the computer on a beach. Like it seems like it has to look like this, but in natural selection, there's no teleology. There's no purpose. That barnacle's there, as you explained, because of generation after generation after generation, slowly growing suited to the environment that it found itself in.
Right. And sorry to interrupt you, but there's actually several species on the planet where, like, for instance, there's I know I'm probably going to butcher this, but there's a certain kind of cave fish that lives in a cave in complete darkness, right? And the thing is, though, is that they still have the little pits where their eyes should be, right? And what biologists found out is that when they catch these fish and they bring them out of the cave and expose them to light and put them in a different environment, they actually started to regrow their eyes. Like their eyes started to develop genetically. And I'll see if I can find the article where I read that in or where I heard that from. But there are several species out there where like they've evolved, they've adapted to be in the environment that they're in. But if you just even make a subtle change to their environment, you'll start to see, these genetic features start to come through because they have a productive value. Like they have survival value in for the fish, or well, not just fish, but for the organism. And so there's several species on our planet where you can actually see that change in the organism's like physiology.